in this section, we're going to talk about the symmetry and the skewness in return distributions. So let's go ahead and jump right into it to see what we mean. Suppose I have these three specific points as a rudimentary example here, and these points are 4, 5, and 6 as shown. And if I wanted to take the mean of this, it would simply be 4, 5, 6, the summation of 4 plus 5 plus 6 divided by 3, and that would be 15 divided by 3, and that would equal 5. And then once I know the mean, I can then compute the variance here, right? And if I were to compute this variance, I would get a value of 0.67. And then if I take the square root of that, I would get the standard deviation, which is 0.81. And so we know this basic information here. And really the whole point of this section here is to understand the importance around the symmetry around the mean of a particular return distribution. And it's extremely important, especially for investment managers who want to understand what percentage of their returns are around the mean versus outliers. And so typically the more around the mean, the more around the mean, the safer return on portfolio. So to do that, let's go ahead. As mentioned here, we want to understand the symmetry around the mean of return distributions. And so I could do that simply by plotting a graph where on my x-axis I have a portfolio return percentage, and on my y-axis I have the probability of it falling between a certain range, right? And so now there's a function, and this is called a normal distribution function. And there's a function for this, and that function is somewhat complicated. It looks like that, where your sigma here is your standard deviation, and your x is your value, and your mu is your mean. And so the function, if you plot it, looks something like a typical bell curve. It comes to be something like that. And if we plotted our points from our previous example, right, of 4, 5, and 6, we would get the mean at 5 right here, and then one standard deviation, which is 0.81. So if you were to go to the right, you would get a value of 5.81, and one standard deviation below the mean, it would be 4.19. And so now if we want to know what is the likelihood a certain value falls between let's just say between the mean 5 and one standard deviation away from that, which is 5.81, there's no real good way to do that unless you know a little bit of calculus here. And again, we don't need to know that for the purpose of this exam. And in any case, this is a pretty hard integral to do, but you would have to take the integral of the value between 5 and 5.81, which would essentially help you calculate the area. You could, of course, estimate the area, but if you want to be more precise, you would take what's called the integral of that. And if you know your calculus, it's essentially the integral between 5 and 5.81 of that function. Now, that integral is pretty hard to do, but if you were to do that, you would get a value of 34%. And similarly, if you were to do between 4.19 and 5, you would also get a value of 34%. So what that means is the area of this entire shaded region is essentially 68%. So what this implies here is that there is a 68% chance that the portfolio return is within plus or minus one standard deviation of the mean. And here in this distribution where you see the equivalent number of positive and negative values, from the mean is called a normal distribution, as we talked about earlier. And in a normal distribution, you have the mean is equal to the median, which is equal to the mode. So in this case, the mean and the median are definitely equal. And the mode is just kind of, it's too small of a sample size to really have a significant mode here. But essentially, that is what you're looking at. Now, there are times when a distribution is not necessarily normal or symmetrical. And in that case, we have what's called a non-symmetrical distribution, and those are typically called skewed. Sometimes they can be positively skewed, and if a distribution is positively skewed, the curve comes to be something like this. And in this curve, this section here represents frequent small losses, and this section here on the right represent frequent small, few extreme gains. And in a positive skew, you want to find the median here. And the median is where the area on the left is equivalent to the area on the right. And if I could probably estimate, right, where the median is, of course, this is not an exact science. It is right around there. And that is essentially where they're sort of equal. Now, you can see here that there's a long tail where I'm putting the cursor. And that means that it's going to drag, or, if you wanted to balance this curve somewhat, if you put a fulcrum, where would you put it? That would be where your mean goes. And so if I had to estimate that, I would probably estimate that to be right around there. And so this implies here, and you can see the mode is even less than the median here and the mean, because the mode, the most frequent values here are occurring to the left of the median. So typically, investors prefer this positive skew because the mean falls above the median. And so typically, investors are attracted to that. Now, on the opposite end of the spectrum, we have what's called a negative skew. And a negative skew looks almost inverse of the positive skew. So if we were to draw that out, it would come like that. Your median, the point where your area on the right would be approximately equal to the area on the left, is right there for an estimation standpoint. And the mean would probably be right around there, the point if you had a fulcrum on where you would put it to sort of balance out. And in this case, the mean is less than the median, which is less than the mode. And the median here is essentially like what balances this, if you imagine it as a fulcrum, right? Where it would be balanced. And your mean is typically greater than your median here. And in a positive skew, typically your mode is less than your median, which is less than your mean here. So because so investors typically prefer positive skew because the mean falls above the median. Now, if we have a negative skew, the graph looks like this, and here the median is above your mean. And so in this case, the mean is less than your median, which is less than your mode. It is the exact inverse of that. So now let's say I have the following table where I have the following returns, and I have the mean of 11.64 and a standard deviation of 13.65. And if I wanted to calculate the degree of skewness, what we talked about in the previous slide, I simply follow this formula where n equals the number of observations in the sample and s is equal to the sample standard deviation. And so if I were to follow that here, knowing that I have my mean and standard deviation, I would plug it into the third power, right, over there, and I would get the value for the right portion of the equation to equal minus 0.3669. And then if I were to add in the left portion of the equation, I would get a value of 10 minus 1 times 10 minus 2 times the negative 0.3669, which would equal a negative 0.05. Now, this implies this is a negative skew. So the curve is, the distribution is not necessarily normal. It's almost close to normal, but it's slightly skewed to the negative.